Today's lesson is on the other fundamental theorem of calculus. And it starts the idea of taking the antiderivative and kind of another method of calculating the sum under a curve between an interval. So starting out, I want us to review the power rule for taking derivatives. So we all know the power rule, it's super easy. If you have f of x equals x to the n, and let's just say I'm going to add in like a constant for this. And then when we take the derivative, you bring down the power rule and then you subtract, or you bring down the power and then you subtract 1 from the power. And then the derivative of a constant, it drops off. So now what we're doing is, if we have f of x, we're going backwards. So the power rule in reverse. So let's say we start with x to the n. Then going backwards, the integral, we have to add 1 to our power and then divide by that power. And the idea of going backwards is, so if a constant drops off, then a constant has to go back on, but we don't necessarily know what that constant is when we're moving backwards. So we just always put plus c when we're taking the antiderivatives. Okay, so let's do some examples. We'll start with a super easy one, and then I'll do one that's a little bit more challenging. So if we just have x to the 4th, the antiderivative is simply add your exponent, add 1 to your exponent, so that becomes x to the 5th, and then divide by that exponent, plus c. So let's just look real quick. So now let's take the derivative of what we wrote and see if it goes back. So the derivative of what we just got, we would bring the exponent down, so 5x, and then to the 4th, and then the derivative of a constant drops off, and then these cancel, and there it is, x to the 4th. So that's going backwards to kind of check our answer. Okay, for our second example, I'm going to add in some more complicated powers here. So equals 4x to the 3rd plus the square root of x plus 2 over x squared plus 5. Before taking the antiderivative, I'm going to rewrite this as 4x to the 3rd plus x to the power of 1/2 plus 2x to the power of -2 plus 5. And now let's use the power rule for antiderivatives. Okay, so we have to add to our exponent and then divide by that. So 4x to the 4th and then divide by 4. Okay, now we have to add 1 to 1/2, so that's x to the power of 3/2, and then you divide by 3/2. Plus, okay, we need to add 1, so that exponent has to get a little smaller here. So 2x to the power of -1. I mean, it's bigger, but it's like a smaller negative. And then divide by that power. Plus, now going backwards, a constant, you have to think, okay, well, derivative would be if you had 5x, what's the derivative of that? That's 5. So now going backwards, you just add on the x, plus 5x. And that's to the power of 1 divided by 1, but we don't need to write that necessarily. So let's clean this up a little bit. So here these cancel, so this is x to the 4th. Dividing by 3/2 would be the same as multiplying by 2/3. So 2/3 x to the 3/2. And we could write that as the square root of x to the 3rd. But I'm just going to keep it like this for now, I guess. And then this is minus 2 over x plus 5x. So here is the antiderivative of the power rule. If we take the derivative of this, we'll go back to where we started. Okay, now trig functions, but just looking at cosine and sine so far. So derivative of cosine, antiderivative of cosine is sine of x plus c. So we always have to put the plus c. And that makes sense because the derivative of sine is cosine. So it's just going backwards. So now the integral of sine is negative cosine x plus c. Because you have to remember the derivative of cosine is, so derivative of cosine is negative sine. So now we're starting with a positive sign, so now our answer is negative cosine. And always have the plus c. And now for the second fundamental theorem of calculus. So what it is, if you have a function that is, of course, continuous on an interval a to b. So this is of a definite integral, meaning we are finding the sum under a curve from a to b on this interval. Okay, so I have the integral from a to b of a function. It is equal to the antiderivative evaluated at b minus the antiderivative evaluated at a. So once you start learning antiderivatives, you no longer have to do those Riemann sums. Okay, so let's practice that. So if I have the definite integral, I'm finding the area under the curve from -1 to 4 of the function 4x plus 5 dx. So to do this, we have to find the antiderivative. So this is power rule. So I have 4x, this now increase your exponent by 1, so x squared, and divide by that exponent, plus the constant 5 needs to get an x. And then I'm not going to put the plus c because once you do the fundamental theorem of calculus, they would just cancel out. So when we're evaluating, we don't need to put the plus c. And we are evaluating, so this is just kind of taking your integral and placing it here, the information. So we're looking at the antiderivative, and then we're going to evaluate it from -1 to 4. So we're going to start by plugging in 4. And when I rewrite this, 4 divided by 2, this is just 2. Plug in 4 squared plus 5 times 4. So there's the antiderivative being evaluated at 4. And now I'm going to subtract, plugging in -1. So 2 times -1 squared plus 5 times -1. So here, 16 times 2, that's 32, and then I have 20, so 52 minus, okay, this goes to +1 times 2, and then minus 5, so this is -3, and 52 minus -3 is 55. All right, next example. This will be the last example of the video. So let's find the area under the curve from -pi to pi of cosine x plus 4. All right, so first, antiderivative. Antiderivative of cosine is just sine. So sine x, and then antiderivative of 4 is 4x, and then we're evaluating the antiderivative from negative pi to pi. So first, plug in pi. Sine of pi plus 4 times pi minus, plug in negative pi, so sine of negative pi plus 4 times negative pi. Okay, sine of pi is 0, so here I'm just left with 4 pi minus sine of negative pi, same thing, that's 0, and that goes to minus 4 pi, so this would equal 8 pi. So there's your full video on starting with the idea of antiderivatives and using the power rule. So we're obviously going to learn some more techniques for antiderivatives, and then that fundamental theorem of calculus and evaluating those definite integrals. Good luck with your lesson.